These are our efforts in spreading awareness and knowledge sharing for the tech ecosystem at large. For this inaugural session, we had Dr. Georgios Pappas speak about the hybrid worlds powering the industrial metaverse with AI, IoT, and immersive XR portals, organized by GRAHAs VR. I'm Sriram, the co-founder and CEO of GRAHAs VR. It's my absolute pleasure to be your MC for this evening. It will be an insightful session as we dive into how the convergence of next-gen technologies are creating new reality for industrial operations, boosting efficiency, eliminating risk, and unlocking exponential value for the users. To set the tone for the evening, I now invite Dr. Rajaram Venkatraman, convener and head technology panel, WIKI, Tamil Nadu State Council, to deliver the welcome address.
Thank you, Sriram.
Thank you, sir.
Happy evening, everyone. A warm welcome to this transformative session on hybrid worlds powering the industrial metaverse with the AI, IoT, and immersive XR portals. See, we are in a new industrial era. Rather, we are standing at the threshold of the fourth industrial revolution's next chapter. Today, we are not just discussing technology, but we are exploring the fundamental reimagining of how industries operate, innovate, and create value. The convergence of AI, IoT, and extended reality is creating what I call hybrid worlds, the digital and physical ecosystems that are reshaping the very foundation of industrial operations. So if you look at AI, which is the intelligence behind the revolution, it is not just another technology or tool. It is the cognitive engine that transforms raw data from IoT sensors and immersive XR environment into really actionable intelligence. That is the power of AI. It serves three important functions, critical functions, I would say. Predictive intelligence. The algorithms, AI algorithms, they analyze vast streams of sensor data as well as they predict equipment failures before they occur, reducing downtime by up to 50% and maintenance costs at least by 25%. So that is the first one is about predictive intelligence. Second is about autonomous optimization. See, it doesn't expect a human to intervene. The machine learning systems, they continuously optimize the production processes, supply chains, and resource allocation in real time, delivering efficiency gains that really human operators cannot achieve alone. The third aspect is the intelligent decision support. AI provides workers in extended reality environments with contextual information, safety alerts, and procedural guidance, transforming how we train, operate, and maintain complex systems. So, what is the business imperative? Why act now? The question is whether it is not about whether industry will adopt these technologies. It is the question is about whether you want to be a leader or a follower in this transformation. Companies implementing industrial metaverse solutions are already seeing 30 to 40% reduction in training time through immersive VR simulation, 20 to 25% improvement in operational efficiency, significant cost savings in prototyping and design through digital twin technologies, enhanced safety records through predictive maintenance and VR-based safety training and all that. So the question is, again, it is not about whether your industry will adopt these technologies. It is about the industry or your company want to be a leader or a follower in this transformation. I think that has become the question now. So the future is going to be a hybrid. See, the industrial metaverse represents more than digitization. It is about creating hybrid worlds where physical and digital realities seamlessly interact. See, imagine a factory floor where technicians wear AR glasses that overlay real-time AI insights onto the equipment, where maintenance procedures are guided by intelligent avatars. And global teams also can collaborate in shared virtual spaces that mirror the physical operations. So this is not science fiction, right? Companies like BMW, Siemens, Nvidia are already deploying these solutions today, creating competitive advantages that are defining the market leaders for the next decade. So earlier, we all know something complex or looking very futuristic, we will say, hey, this is rocket science, right? Are you doing rocket science? So, and avoid that. The sense, hey, that is complex and we can't do it. That kind of paradigm. Those days are gone. So if you see what is happening today at IIT Madras, the same rocket science itself, right? Our guys at IIT Madras, Agnikul Cosmos, they are doing 3D printing of the rockets and are sending to space. They have already done the launch. Their goal is to make space easily accessible. They have their own private launch pad at Sriharikota, private launch pad, Agnikul launch pad, right? So what I am trying to say is these are technologies which may look like science fiction, but not so. In the very near future, people have to implement. People, who are implementing will become leaders, and who are lagging behind will, face the reality. So the journey starts today. As we embark on this session with Dr. Georgios Pappas, we remember that every revolutionary technology was once considered optional, right? Until it became essential. The industrial metaverse, powered by AI and immersive technologies, is really crossing that threshold now. The organizations that understand and implement these technologies today will be the ones who are setting the industry standards for tomorrow. Those who wait will find themselves not just behind competitors, but operating in an entirely different reality, right? So before we begin, I also want to, take a moment to shine some light on the passionate minds behind this initiative. The co-founders of Squarecom Solutions, GRAHAs VR, the creators of GRAHAs VR, Srini and Sriram. So GRAHAs VR is not just a technology platform. It is a vision brought to life by a young and dynamic team that believes in transforming how we experience the world, virtually, intelligently, and immersively. I asked them, hey, why did you name this series as a Visionary Series? Right? The answer was very interesting. One, they want to be part of that new vision in terms of transforming enterprise, right? That is the typical one. Second one, they said, is humorous as well, is that, hey, because this is about the VR, AR is all about looking through the eyes. So it is also a visionary series. So from industrial metaverse solutions that help factories visualize operations in real time to immersive educational content that makes learning interactive and intuitive, their work spans a remarkable spectrum. They have built training modules for corporates, virtual museums, where you can pet a cow and things like that. Virtual museums for social impact, extended reality portals for business and marketing use cases. Each project reflecting both innovation and purpose. What stands out is their ability to bridge imagination with implementation, taking virtual reality beyond the headset into spaces that truly empower people, industries, and communities. Whether it is enhancing worker safety in hazardous environments, exploring kilometers in minutes through virtual tour, are enabling business leaders to visualize insights in 3D. They are creating real impact using cutting-edge technology. GRAHAs VR has always been at the forefront of driving innovation, of making it accessible across industries and enterprises with their implementations. What started off as a smartphone VR headset has grown enormously in terms of deployments and value creation across different geographies and industry segments. Some of the things they worked around industrial segment, engineering, automotive, IoT companies, shipping, pharma, e-commerce, life sciences. They've got implementations in various sectors. They are creating value across enterprise with over 4x faster training and 4x more focused solutions. As a mentor and well-wisher of this vibrant team, I feel proud of their progress, and tonight's session is another step in their continuing journey of excellence and impact. So coming to today's keynote speaker, my good friend, Dr. Georgios Pappas, brings exceptional expertise and a unique blend of industry and academia from the Open University of Cyprus. He is a Greek, where his research into educational materials and methodology provides very unique insights into how humans interact and learn from these emerging technologies. He is one of the top game developers in Europe. His perspective will help us understand not just the technical possibilities, but the human factors that determine successful implementation as well. He is a leading light in this XR space, and from August 15th, he is going to be in the US as an assistant prof at Purdue University, where he is going to lead the gaming team there as well. So we are hoping to see some big breakthroughs from the US with all the resources and the intelligence of Dr. Georgios. So let's begin this transformation. Today's session is not just about learning the new technologies. It is about envisioning and planning your organization's future in an AI-powered, immersive industrial landscape. The tools and strategies we discussed today could be the foundation of your competitive advantage tomorrow. Welcome to the future of industry. Welcome to the age of hybrid worlds. Thank you. Thank you very much for the invite, and let's dive into this exciting journey with Dr. Georgios Pappas. Thank you once again.
Thank you, Dr. Rajaram, for your kind words and for laying the context of today's session. It's now time for the keynote address. It's my privilege to introduce Dr. Georgios. Dr. Georgios Pappas is a game developer, researcher, and educator at the forefront of immersive technologies and serious gaming. He holds a dual Ph.D. degree in electrical and computer engineering from Michigan State University and the National Technical University of Athens, becoming the first graduate of the joint doctoral program. An MIT IoT Bootcamp alumnus and invited instructor at the MIT Deep Tech Bootcamp, Georgios currently contributes to the educational innovation at the Open University of Cyprus, specializing in gamification for distance learning. He is also the incoming assistant professor of practices in game development at Purdue University, USA. With award-winning work spanning in games, XR, IoT, AI, and simulation, Georgios continues to push the boundaries between the digital and physical worlds through hybrid, technically integrated learning environment. Over to you, Dr. Georgios.
Hello, everyone. First of all, before start this presentation, I want to thank you all for the invitation. I always feel very close to India and Indian people. I have many collaborators, so it's a great pleasure and honor to be with you. I have great respect generally for your civilization, not only us, the Greeks, but also India share a great civilization over the years. And we, as nations, try to be pioneers in what we call history over the years. So that's using this, legacy that we have as people. I think there's great opportunity to collaborate with each other. And this is what I try to do, having many friends and collaborators from India over the years. So I don't want to lose time from the presentation. Starting sharing my screen here. Um, let me. Can you tell me if you see my screen? Let me switch this.
Yeah, it's visible,
Swap.
Dr. Grant.
Yep. Okay, so I think the introduction you already mentioned a few things. The one thing that I would like to give is that I'm a passionate game developer. I have seen the whole game development, um, area from different perspective, from having a startup, being in the industry, doing that for academia, doing that for research, and actually apply that to many and different industries. I have affiliations, as you mentioned, with many universities over the year, and I soon start at the US at Purdue University, where I will be teaching game development there. So, what is this presentation about? I want you to understand this bridge, what we call the hybrid worlds, is where the real world and the virtual world is merging. So, this presentation, I don't want to sell theory. I will show you projects, hands-on projects that we do for education. We do that for the industry. We'll show you game development projects. I know you do a lot with VR. I do many uh, desktop applications that can be expanded to VR, but since we have many students that do not have goggles, we made desktop builds in order for them to be more accessible. But this actually can expand a lot to VR. And I will share you my story, how I work uh, with all that. I started from there. This is the National Technical University of Athens. This is like the IIT that we have in Greece. It's our greatest institute in terms of technology. It's the MIT of Greece, let's say, and it's a purely engineering university. It's like Polytechnic, we call it Polytechnion, Metsovion Polytechnion. And while I was there, I was a student in undergrad. I together with three other people, we started creating a game while we were in a freshman year. And it was our project that it was an idea of ours that started and we built a game from scratch, even without using game engine at the time. So imagine about 20 years ago, we were 18 years old, that we got up together and we put our talent in order to create something. And actually it was about a historic event. In Greece, it was about the revolution we had back in 1821 and the liberation from the Ottoman Empire. And we imagine that, okay, we have so many companies, foreign companies that use the Greek history. I'm sure you know a lot about Greek history and the mythology and in the ancient Greece, Sparta, this is, I think, familiar to all the world. But the modern history was not actually so, uh, you know, um, marketized, let's say, in the public. So this history, the liberation from the Ottoman Empire, is something that's a very sensitive event for our people in Greece. So we thought with each other, why don't we build a game, a Greek game, one of the first Greek games ever made in Greece? Why don't we start and make a project? Uh, at the beginning, it was a student project, but at the end, it resulted to be a bestseller project. Imagine that when we were at our third year in the university, we had actually a company of our own. We published the game and actually made a bestseller game in Greece, and we even started the community of game developers back then. So it was actually my first, interaction with game development and seeing tools, how to make these interactive tools, and actually for a historic event. We, as you can see here, it was a big thing for Greece back then. We had interviews from many magazines. We had interviews from many TV stations, and actually even the PC magazine and all the magazines related to games and technology actually were writing about our game. And even we had, 1 month we were top of the charts, even from all the top selling titles, even the foreign ones. We imagine that we did something as a student project that resulted to be an industry, product. So it was a very unique experience for us. But over the years, I started doing other projects. I did a lot with hardware. with microcontrollers. This was a D-class audio amplifier. It was an audio. I also did the audio for the game uh, back then. And after that, over the years, I was working before doing actually my PhDs. I was working as a software engineer and actually was behind uh, the creation of the integration, the API integration between the largest IT company in Cyprus and Cisco. So imagine I worked business to business integration in order to get all the information from Cisco server into the ERP of the company. So in here, I learned a lot about APIs and how to make DLLs and dynamic libraries. And actually, what I built was applied in 17 countries. Over the years, I was working a lot with also with XR. I was the key organizer of the first exhibition event in Cyprus. And so what you're hearing right now, I am sure for some of you feel a bit disconnected because you saw about game developer. I told you about game engine and AR. You saw an AR project just before XR. You saw hardware design and microcontrollers, software development, APIs integration, and authorization methods because the APIs were securely connected with each other. But what if I tell you that all this information I got over the years from the industry, from the university, from whatever project I did was like a puzzle. Imagine that all this information could be like a puzzle and maybe we can find some secret connections in order to create something more meaningful, projects that can be applied in many different fields, but we can use technologies, the one that we now call metaverse. Metaverse is actually uh, the sum of many technologies together in order to create some virtual world. What if I tell you that this actually is combined of many and different puzzles? And let's start putting these puzzles together. When I was back in 2017, I was selected at the MIT IoT Bootcamp, and there I learned a lot about IoT microcontrollers. But I said to myself, okay, I know game development. I can build with game development and different plugins. I can build XR like AR or VR. I could use APIs integration that I learned actually from the company I told you before, and I could use IoT and sensor data in order to bring this information inside the virtual world. And this is actually what I built. Actually, this is an AR application that imagine that it has different images. The images were getting live. And in here, you could see the temperature sensor changing in an augmented reality environment in real time. So we could have sensor data connected to a microcontroller. This microcontroller was submitting this information to the cloud. Here is the cloud, the dashboard of the cloud. And from the cloud, I was importing automatically the data inside the AR application. So imagine you could have real time or low latency data in the virtual world. In the virtual world, in this sense, it was XR and particularly AR. So in there, I actually understood that all these technologies are actually there is a strange combination between them in order to create, more meaningful application. Actually, this project, at the MIT, they really liked this project, and after that, I had many partners, and even my MSU advisor when I did my second PhD at MSU was from MIT. It was my lead instructor at the MIT Bootcamp. So this project was a key to many things. So in here, you could see a lot of projects that I did with many institutions, including even IIT Madras and also the military in Greece. And I will start showing a few applications that I created over the years. The first one, this is for the Open University of Cyprus, and this is how we started. It was just a pencil and a paper. And what is about it? The problem was that at OUC, our students are distance learning students. So they are not, all in the class. So imagine that in order to do this master's degree, the students needed to go outside in the forest and get pictures and get information that somehow, first of all, can be dangerous for them. And secondly, because we have students from all over Greece, Cyprus, and many other countries. Imagine that all the students do not have this opportunity to go and find the forest. Imagine that they could live in a major city and there were not, a forest around them. So what we actually did is said, okay, why don't we create a virtual world, a virtual tool that the students could, move around and get this information in a virtual uh, condition. So after we had this pen and paper on what we wanted, we needed, hills, we needed grass, we needed mountains, we needed different kind of plantation that we need to have there. Uh, we designed the features. We had a virtual ecosystem environment. We have a first-person movement like the FP games, the FPS, for example, from the games. We had a compass. We had a local coordinate system. We had a minimap, and actually we had the IoT implementation. So you will see how it works and how it can be combined also with IoT. In here, under every project, for those you are more interested in also see the academic stuff behind it, you can see, the publications for those who are interested. But for those who want to see more of the applied things, you can, I have videos for every project that you will see. So in here, you can see that the players can move around. I built a system like a virtual drone system above them. So imagine that we could have mini map and we have this max map here. And our student actually gets print screens from this information and actually use this information for their projects. So for example, in here, you can see this is 160 meter by 160 meter, and there are certain number of trees. So they can get print screen from this and actually take measurements and use that for their project. And also they have these virtual coordinates with X, Y, Z. So the professors, the tutors know exactly where the student was in order to get this information. We have the virtual compass system, and we have a mini map in order for the students to see where they are moving. Also, they have land, but we also have, water. And for those who are wondering, no, if you go underwater, you don't die. You just see the underwater area. And the plan in the future was to, add fish, add animals in order for the students to even interact more with the virtual environment. One more advanced feature is that we have portals, remote, we can teleport in specific areas. So by pressing one button, we can get to specific coordinates. And in the specific coordinates now, why they are important? Because imagine that this tool right now is a tool for asynchronous learning. So the students download the game, they can take their measurements, they can get their screenshots, but they can do that at their own time, at their own place, uh, anytime they like. But in here, when they go to the specific locations, I made the this connection with the IoT connection. So this is a microcontroller again, and there is a button here. It could be a button, it could be a sensor. We could change that on whatever use we'd like to do. And the tutors, by pressing this button, just pressing this button, this information on off is sending to the cloud, like what you saw the other project before. And when uh, they press the button, it transmits the on signal. And the on signal practically for the game means I program it to mean that, okay, can you trigger and appear new stuff in the game? And for this case, what we actually do, by pressing the button, you can see that these trees are getting on fire, and we have educational material that appears only the time that the tutor presses a button. So you could have a tool that is actually um, a tool that is actually for asynchronous and synchronous learning. So by unpressing the button, you could see that it transmits off and comes back to the original state. So we could have a virtual environment, we could have information and educational material within, and we could have the IoT implementation inside the virtual environment that changes the whole experience, making it a synchronous tool for learning. So what can we actually do? Beforehand, we saw that we had to have game development desktop application, we would have authorization methods because the information from the sensor is getting, with secure methods, that we could have the microcontroller and the sensor. What if we now an XR layer and we can create the so-called digital twins? The digital twins can be applied, in many areas. For example, in the industry, and we call them the avatars. The avatars is avatars and cars. So we created with the same logic, different application. This actually was a collaboration with the MIT. This area here is actually Cambridge and Boston in the US. And what we actually did was we could create an AR, a VR, and a desktop application where we could actually monitor the dashboard and the information of a car in real time by getting the information via sensors. So in here, um, you could see the virtual car or the avatars. We could have, this is the AR application. So imagine we could have this tracking image. We could use a mobile phone, just a mobile phone, and it automatically creates the map based on the location where the car is. And we could have the dashboard, the speed and the RPM in real time of where the car is. This is the augmented reality part. There is also the VR part. In the VR part, this is a low polygon, but imagine that we can expand that into a lot greater graphics now with very advanced models with goggles and VR headsets that there are in the industry. This was a proof of concept using Google Cardboard, to be honest with you. And imagine that we added a dummy file from Paris. This is here the Eiffel Tower. So we could have the latitude, longitude, and you could see here, if you could notice, it was actually the change, the real-time change of the speed by changing the dummy file that we provided. This is how it looks. This is a low poly because it was Google Cardboard, but imagine, I know that you do a lot with more advanced graphics in terms of XR. It can obviously expand to a lot more graphics if somebody wants to do that. Also, there is a desktop applications for monitoring multiple cars. Imagine, for example, that Uber can, can actually have digital twins for all their fleet. They could have maps, and they can pinpoint everywhere in the map, and they can know exactly how the driver drives their Uber, their taxi, and they could have a holistic map with all this information. So this is the same principle, but for industry. Coming up next, you saw the low poly, but let's see the other side. What if we add photogrammetry in game engines? This is another technology that we could have the absolute reality, because we have 3D scanners in order to bring the real environment into the virtual world. And for example, the image you see here is from Quixel Megascans from Unreal Engine, but there are many applications that we could do also with Unity. This is a project I did for education using this principle. What we have game development for education, again, adding photogrammetry in order to create this experience. Dr. Rajaram, before when he was making the introduction, mentioned about virtual tours and museum. This is exactly what I did for students. The Ancient Theater of Philippi, first of all, is in the northern Greece. It's an ancient theater, and I collaborate with a company. This is for OUC. In here, you can see that I created an input field that the students actually select in which program of study they are studying. This tool actually is used for 2 programs of study, for 2 master's degrees. One is studies in Hellenic culture, and the other is the theater studies. So it combined both. And this is actually what we built. Well, in here, you can see that we have 4 different levels. The levels are the same visually, but it has different educational context. In here, we have the architecture. This is the drama. This is the comedy. And this is the ancient theater battles that they have in the area. So we have different content in terms of what the students are learning. So when the screen loads, you can see that this is the actual theater. We can move around in first person. This is the exact, scenery of the theater, and the students can move around. We reconstructed it with about 5,500 photos. There were photos both close up and also with drone. So we have great accuracy of the real area. So in here, we can move around. We can have educational videos. So this is a professor at OUC that actually mentioned it's a chunk of lecture. It's about 5 minutes that explains the basics and actually provides the students some information what to study in order to play this level. And after the students are have studied the material, they can locate these hotspots here. And the hotspots actually are questions. There are random questions. There is a question bank behind with a question randomizer, and they have time, and they need to actually have an 80% of correct answers in order to pass this assessment. Also, there are the hotspots are randomized. If you can see here, in whatever area of the theater the student is moving, it is changing this. This is information of what the specific location of the theater is called. This is the theatron is called. If you go in the middle, for example, this changes and it's called orchestra. That's how the part of the theater is called. When the students have successfully completed this information, I made a different integration. All this information automatically feed a Google form. The student never go to the Google form. This is automatically done by the tool. And this automatically feeds a Google Sheet. So at the end of the day, the tutors get all the information that at this time, this student's name, surname, the email, at this level, they got this score. So imagine that they play the game and at the same time they have assessment and the tutors know exactly what the student did. And I will show you this example. This is a very important example. I told you about photogrammetry. I don't know how many of you know Notre Dame. Notre Dame is actually is a church, is a monument in France, in Paris. And actually, some years ago, there was a catastrophe. It was destroyed by a fire. So what the government did? It's a UNESCO monument. So obviously, the president of France wanted to restore it and reconstruct it as fast as possible. So if you know the story behind it, back in 2014, Ubisoft, which is a great company, great game development company that actually creates the series of Assassin's Creed, they actually constructed the 3D model of Notre Dame using photogrammetry. So they reconstructed all the church for the gaming reasons. So they use it. This is a screenshot from the game, the Assassin's Creed Unity game, and actually provided the model to the government in order to have every detail to reconstruct it. Imagine that the gaming industry actually will help to restore a model using the photogrammetry method. So we have game development and photogrammetry with great impact. Coming up next, we mentioned before about photogrammetry. What do we have? We need to make our students, or we will have to have exhibitors in order to create a virtual exhibition. We have data, we have images, we have text. What if I tell you that we can create virtual exhibitions and we can see around that, we can move around, we can see different artifacts, different paintings, but the clue behind this painting is that they are not inside the game. All these paintings are outside the game, and the game automatically loads them. So imagine that you have a directory, you place all these images, you place all the information who make this painting, and you open the game, and automatically it creates this exhibition. So we could have external data in order to create virtual exhibitions. In here, for example, I didn't add data. So it's like you have slots in order to create this monument. I left them on purpose in order to see that if I add data in certain locations, they automatically appear inside. And at the same time, by using just one button, we can make that bilingual. We could have the exhibitor, the name, the surname, and all with a click of a button. Coming up next, what if we use research data with game development? So how many of you have seen similar photos? We have field research, we have certain measurements, we have certain formulas. What if we translate this information to more meaningful, to more, make sense for more people, not having like this that we do not understand. This is only for the academics, for the scientists. No, what if we get this information and we create monitoring tools? For example, in here, imagine that we could have all this information input in this field. This is for stakeholders, not only for students. We would have a virtual city, and by adding all the information of the city, we can get real-time monitoring on what's the process, how this city performs, what are the actions taken in order to create a green city, a virtual green city. This is not only for student learning, but actually for stakeholder monitoring. Imagine that this tool, we also want to give it to mayors and other key stakeholders in order to have a vision of how their area, their municipality, or their city performs. In here, we have certain metrics on what they do, for example, in food waste, what they do with plastic, what we do with PMD and other organic waste. And we could all have these KPIs, these key performance indicators, in order to have a virtual monitoring of a city. Coming up next, and this is actually a project that I did with India, with IITM and the Energy Consortium. What we actually did, it's similar to the other project, but this is for energy efficiency. What we actually did with our partners with IITM was actually having a virtual model. This is not the exact model, but a representation of a pharmaceutical company in Bangalore, in India. We had the energy audit of this pharmaceutical company, and actually we had some measures. These were all written in PDFs in order what to do with the compressor, the cooling tower, the chiller, the boiler, the transformer. We had all this information, but it was in an audit report. It was more difficult to understand for somebody to read 100 pages, even more, with all this data and what to do. But this game, actually, you take the role of a stakeholder, maybe the CEO of this pharmaceutical. You move around, you have certain panels there, for example, like this, and you read the metrics. And the panels also provide information on what key action you can do and what will be your savings in terms of money, in terms of CO2 emissions. And you could have also, the total investment in a year, 2 years, and more. So at the end of the day, we could train, stakeholders in order to understand the benefit of making key actions, maybe with a small investment at the beginning, but a great outcome in the end using tools like that. So we have energy data leading to energy efficiency via gamification. Coming up next, whole different area, cybersecurity now. What if I tell you that we could create a hybrid worlds with cyber escape room games? So the idea behind this project was to teach people on cybersecurity concepts. But if they manage to get this, codes by solving different mysteries, different quizzes, they could get, passwords in order to escape different doors. This here is this is a 4th-floor exploration office. We could move around. We can locate different kind of files. We can even locate videos in here. You could see monitors. Okay, you can see here this monitor and you can see this monitor, but this monitor actually streams video, external video. This is from YouTube, but it automatically shows the video within the game. We can find, USBs that are within the game. These passwords, I need to mention that every time you open this game, there are different passwords, and they are encrypted, so nobody can find them and actually decrypt them in order to hack the game, let's say. And the most important thing is that this area here, it says press E to use this computer. By pressing E, you can see that in the game, okay, it automatically opens a browser. So you are in a VPN and you go to a CyberAge environment where they use their credentials, the trainees or the students. They get inside and they do real testing, penetration testing and other cyber security tests, and they get the final password in order to escape within game. So imagine you have the game, you go outside the game, do other kind of testing in a CyberAge environment, and then get back to the game. This is a total hybrid world game in order to understand more critical elements about cybersecurity. And that's how you escape the last door. Coming up next, this is our own ChatGPT. This is a human to AI interaction. I will add the AI element now. We created the Oracle numbers. I don't know if some of you know the game, the Mastermind, that you need to find where the location is of different colors. It's a popular game, board game. This is similar but has some differences. We have the Oracle that gives these 3 numbers. They are binary numbers, but you could start with some zeros and some ones, but not everyone is correct one. So the students need to find the exact prompt of the total these prompts. We have 1 prompt, 2 prompts, and 3 prompts. And in here, when we got the result of the 3 prompts, we have 2 actions that we do. 1, the students need to understand the mathematical equation, so they need to provide what's the meaning in theory, let's say, the mathematical approach. But at the end of the day, we need people that are hands-on. We need people that are engineers. We need people that are making stuff. So what can actually the 1s and 0 mean? Can mean press the button or not. So we have in here, you can see that there are buttons, virtual Arduinos, that when the students select the correct sequence of the prompts, actually they get a congratulations LCD in here. Coming up next, again with AI, this is an even more advanced project and actually can be applied with self-driving vehicles and the industry. We have a gamified tool, and we could have 2 different kinds of AI. One AI could be a rule-based AI, and the other could be a model that we train after we create the synthetic data. We can also have a user input. Explaining it a bit more, we have a buggy simulator that can firstly be driven using user input. It's a gamepad. Imagine like you have a PlayStation. So you can move around, and by playing this game, we collect data of our driving behavior. By collecting this data, we could have the speed and the wheel angle. And after that, we create a CSV with this information. And at the same time, we have a virtual representation of a real camera, but in the virtual world. So we get timestamp with a representation of another camera inside this game. So by Connecting all this information, we create a convolutional neural network, and then we create a real buggy, self-driving vehicle, with a similar map, and we actually make this drive itself in the real world by using all the synthetic data we created from our game. But what is better to explain that I can show you in order to understand more. So you can see this selection. We could have the user-driven and the AI-driven. And you could see that we could move around. We have speed. We can have this camera. The camera is in there, so we can see what this buggy sees. So we can move around, and at the same time, we are collecting data. We can see the wheel angle over time. And actually, we could have measurements. The asphalt is changing over time with pearly noise in order to create a variety of data. And at the end of the day, we collect all this information. This is the information. This is the images that we collect. And not only the image, you can see that we also get the CSV file in order to train afterwards the AI. And after that, when we trained the AI, we actually had this buggy in the real world. This is in Michigan State University. And it started driving itself within this map, which was similar to the other map, using only the information from the virtual world. And what if I tell you that we could expand this in order to simulate actual sensors, the LiDAR sensor that is being used in the industry? We actually create a tool that simulates the data from a LiDAR. The LiDAR is a light emission sensor that transmits light in self-driving car, and actually it gets information from the reflection if they see an obstacle. And actually we create a very good graphic game this time, and we could monitor exactly what the area is. And in the virtual world, since we have the ground truth, we could locate different cars. And in here, we create similarly a data set, and we actually manage to track cars in the virtual world that practically do not exist in the real world. But our information was that good enough that we used an AI model that was pre-trained with real data, and the AI model actually tracked the virtual cars. So no, one side is that we made fun of the model, but the other side is that we could use virtual worlds in order to cover edge case scenarios for training. So we could create hybrid AI models using real data and synthetic data to cover these scenarios. Another project, we could use, again, virtual tools in order to raise awareness. We made this tool in order to understand what is the perspective of people regarding self-driving cars, and if they are at the perspective of pedestrians, how they would feel in order to see how they interact with self-driving cars. And imagine that even in the virtual world, at the beginning, if the people did not know if the car was going to hit them, they were afraid of it. But we had a scenario that the self-driving cars would always stop. So after the people knew that, they started abusing them. And by abusing them, even the light was red. We noticed that they started moving, the crossroad, and they did not care if they did not have a green light to go. So we raised awareness, and we even saw different kind of behaviors. The human factors, as Dr. Rajaram mentioned at the introduction, we could see that in virtual world in a safe environment. This is a very nice project. This is one of my favorite projects. This is with military. I did that with the Hellenic Air Force Academy, but it's for a civilian mission. We created a drone project that actually, the narrative of this concept is that we needed to find an orange car that it was a rescue mission. There was a gas leak somewhere, and there was a rescue team that went to find the gas leak, and then it was lost. And this team, after that, because of this hazardous situation was existing, we actually flew a drone. The users actually trying to find this orange car wherever that is in the map. And in here, you can see that they identify, we knew exactly where the orange car was in the urban area. And in the urban area, the drone needs to go to fly above it in order to complete the mission. You can see here we can have speed, we can have time, and we could have altitude. We have a 3-camera application. So we have the gamified tool, and this is what exactly the tool was seeing. Actually, we had testers. They were we tested this tool with combat pilots, air defense controllers, and engineers, and we actually proved that even the pilots, even in simulated missions, they were the best. Even drone controllers, even if they used a gamepad controller. We actually used a PlayStation 4 controller for this information. It was purely civilian mission, and that's why we managed to publish that, and we got special approvals by the Hellenic Air Force Academy to do that. And again, the previous project you saw, it was a project that actually was using a randomized terrain. It was not a real area, but actually there are tools like with GIS, the so-called GIS for AVs and drones. This is TerraLand with Unity. And actually we could have a similar project, but have real areas of the world. So imagine that you could have servers with real areas of the world with specific location, latitude, longitude, with height maps, and actually get some real missions from the real world from specific locations that we need to train people. Other project, this is combining different hardware with gamified tools, and actually this is how to make a hologram pyramid. In here, we could have a hardware with it was a glass pyramid. And actually, we use that for students and from high school students, and not only, even from elementary school visited our hologram pyramid. This was presented at the Researcher Night, which is a pan-European event. And what we actually did, it was we created a tool. You can see here that that was showing in two monitors. The one monitor was the controlling monitor, and you could see this reptile. This is actually, we got information from the real animal. We scanned the animal and we got motion capture from the animal. So that's exactly how it moved. And this lizard, actually, both the turtle and the lizard actually are from Cyprus. So they did all this motion capture information they got there. And this is the four image. It's the 4-angle view. And the 4-angle view, imagine that in here there is a monitor that actually reflects these angles of the turtle within the glass. So it looks like that the animal is in there. So that's how we created this model. We have game developer with external browsing, like making a virtual library. Imagine that our students go there, they can get all the information, and they get different information about journals and stuff like that by visiting this application. This is another project I finished some days ago, virtual courtroom. So the students move inside the courtroom in order to see what are the parts, so how how a court works actually. And summing up, we have the real world, we have the virtual world, and by the virtual world, what we see? We saw games, we have gamified tools, we have XR applications, we have simulators, all the projects you saw. So this is a big bubble that contains everything. And what else we saw? We saw IoT, we saw AI, we saw photogrammetry, we saw GIS, big data, you name it. There are multiple technologies that we saw and we can combine. And again, I'll go back to my puzzles. At the beginning, as I told you, I did different kind of things, but all this information, these are the key parts of the metaverse. And they can be combined in order to create different and meaningful meanings. And that's one of the most important slides. You saw the real world and you saw the virtual world. So when we are in the virtual world, we can have hardware and sensors in order to get information from the real world. We can have GIS in order to have specific locations. We can have photogrammetry in order to get accurate models, and we could have real data imported from the real world using this direction to the virtual world. And at the same time, imagine that we could have human training, raising awareness, we can create synthetic data, and we can have AI model training with using this data and come back from the virtual world to the real world. So this is the infinite loop that connects the real world with the virtual world using all these technologies. So what we have a real and virtual world, and this is the so-called emerging tech infinite loop, as I mentioned it, that's combine and create the sense of the hybrid worlds. And all this together, all these technologies, we can be in the virtual world and the other side can be the real world, but all these portals we can see, we can use this information, these technologies we all have together, we can benefit from them and create meaningful impact, meaningful tools, meaningful applications for the education, for the industry, and for whatever area we would like to make a serious impact. Thank you so much. If you have any questions, feel free to ask.
Okay, we do have a couple of questions in the chat box. So should we take that now or maybe after this? Yeah.
I think now itself you finish it up, yeah, because they are all fresh after hearing him.
Correct.
For the
Let's
last
take
half
the
an hour we
questions.
heard him. With your permission, can I start the game?
Yes, sir. Please, sir.
Yeah, I'm thankful to you for making it very clear that today's world, in today's world, we don't have a standalone technology, and it is always more of a hybrid technology, which has to be accepted, whether we like it or not. Now, there are only two questions out of your lecture. Waste management. In waste management, at least I can talk about India. We haven't yet come up. Like, for example, Singapore waste management, they are able to generate a lot of electricity out of the waste, burning that thing. And even we had this problem, we had this project with the IIT Madras. That is, the plastic waste were used for what he call the topping up of the road. That is, we had that earlier, we used to have that metal road. We used to have now the topping up can be done with the help of that waste which is accumulated. But I think we have to look into waste management in case of, in India per se. I can tell you, at least having got the data for the Tamil Nadu, I can tell you what is it. I've seen when I was admitted in the Atulya, I've seen the smoke emanating from the complete, dumping yard. They used to burn it. Okay, that's a different ball game. Okay,
Yeah, Major,
now
in the interest of time,
I will have only one question. Last question. The question is, he's talking about failure mode. Or is there any applicability of FMEA or MTBF?
Sorry, can you repeat the question?
Yeah, I
failure
can repeat the question. You have talked
Mhm.
about failure mode. Do you have, is your development focusing on FMEA or MTBF?
that is failure mode effect analysis is one approach you must have come
Failure
across.
mode effective analysis is FMEA. MTBF is mean time between failures. And this is more so in the what we have seen it in IG card.
Yeah, those are more of process measures.
I know, but they have developed something which is for failure mode. Can this be utilized so that they are warned?
Yeah,
That's
first
my
of all,
question.
the application, the applications, depending on the type of applications, has some impact in certain areas. For example, the applications that we have, the failure mode, let's say in our application, for example, the education application, is that after we use the applications, we could have certain metrics before using the application, while using the application, and after using the application. So we would have certain measurements on what the people understand, if they get any information, any, if we manage to raise awareness to them, that's a success metrics for us. So we have what Dr. Rajaram mentioned before, the human factors. So if we are successful in informing people on certain areas, for example, you mentioned before the waste management, if we manage to understand what a simple action of them will benefit, the emissions or the costs, or how we do the recycle, for example, that's the important part of us. In terms of failure analysis, it's not how we work in terms of this, because they are mostly educational material. So our metrics, our failure is, for example, the students did not understand. And the failure was that before using such tools, when they only have the paper, a PDF, it was a failure, because even if they read it, maybe they didn't understand. By using these kind of tools, they are making some engaging approaches on certain elements, maybe the cybersecurity, for example. And after that, we understand that the students understand their material, and that's the important factor. That's our success story.
Fantastic.
Thank you.
Yeah,
Thank you.
one
Thank you.
suggestion. Yeah, one suggestion I have, Srini, at this time is since if Dr. Georgios finishes all the questions, that it will take time and people will leave. So we have maybe 15 minutes. You can take Srini to present, and then finally we will have all the questions to Georgios.
Thank you. Yeah.
So we are now moving on to the next segment.
Yeah, we are moving to the next segment.
So I invite Srinivasan, the founder and CEO of GRAHAs VR, to share the implementations of XR domain.
Sure.
Over to you, Srini.
Yeah, you were echoing, Sriram.
Yeah, I'll quickly take over the seat. Now, before I proceed further, I'll quickly play a video on what we do and a snapshot of what exactly GRAHAs VR is about. That way it will set the context, and I'll take over my session post that. Is it audible? Yeah.
The world has changed. The challenges are more complex, the stakes are higher than ever. In this new industrial era, the most critical component isn't just technology, it's a shared understanding of reality. It's always a challenge communicating your complex vision in simpler two-dimensional formats and tools, be it training, marketing, R&D, etc. This creates a reality gap, leading to costly errors, increased time, and slow decision-making processes. This is where GRAHAs VR helps bridge the gap with our extended reality solutions, encompassing VR, AR, and MR. We custom develop XR solutions in use cases like training, onboarding, marketing, maintenance, R&D, etc. for industries and enterprises. We help transform your conventional practices to 3D-based XR solutions. We have solutions deployed across 11 different industrial verticals like industrial, engineering, shipping, pharma, IoT, etc., across 4 different countries, including India, USA, Australia, and Nepal. Our proprietary STEP framework, a proven methodology, is our guiding principle that builds immersive experiences. It's a human-centric approach where story drives engagement, emotion anchors memory, and place ensures skills are instantly transferable. We've been recognized both in India and globally by leading names in the industry like Google for Entrepreneurs, Innovation Leaders Summit, Japan, and were awarded the Best XR Startup in Education and Skilling in the XTIC Summit, IIT Madras by Dr. A.R. Rahman. And one last thing, we're working on an industry-defining product. More on it soon. In an artificially overpowering world, augmenting your workforce with the best suite of tools will be the best empowerment. Let us co-create the future with AI using multiple realities. Check out grahasvr.com to learn more. Follow our social media handles to stay updated further.
Thank you. We'll move on to my presentation. So, just like thanks to Dr. Rajaram initially for the warm words, and thanks Georgios for your great session. So, a quick snapshot about GRAHAs VR to those present here. GRAHAs VR is a brand owned and operated by Squarecom Solutions, and we are at the forefront of the extended reality solution. As a company, we are about 4+ years old, but we have close to a decade in the domain expertise in XR development, and we have been funded and supported by Waytech TBI and IIT Mandi, and we have XR solutions deployed and operational in India, US, Australia, and Nepal. And like mentioned in the video, we focus on 4 different important verticals when it comes to customized XR solutions. They are training, onboarding, marketing, R&D, maintenance, etc. across 11 different industrial verticals like industrial, engineering, IoT, farming, hospitality, e-commerce, life sciences, healthcare, etc. And this is a quick snapshot on what we do. We have our proprietary STEP framework, which stands for story, emotion, and place. Now, for instance, if I tell you 5, 6, 8, 17, you probably may not remember these random numbers, but when you associate a story towards this particular number and there is an emotion and a location angle associated with it, that actually gives you a larger and longer memory retention, and you're going to be more focused on what you get trained on. This is probably in the interest of time, I'll quickly move on to our case studies and we'll be able to elaborate it on a different session. These are some of our partnerships. We are partners with Microsoft for startups, Google for startups, FICCI, NASCOM, Metaverse Standards Forum, NVIDIA, etc. And we are recognized by both Indian and international brands like IIT Madras, IIT Mandi, and we are also awarded the Best XR Startup in Education and Skilling by IIT Madras in the XTIC Summit by Dr. A.R. Rahman, and we are also part of the International Trade Council. Now, moving on to throwing some light on the numbers. With our solutions, we have saved over 80% time on the plant or factory tour, and to date, we have trained over 250 plus professionals across different elements of VR and AR, and there is over 40% reduction in the overall time taken to train. And like Dr. Rajaram mentioned in the initial address, we know the people who get trained on our XR-based solutions are 4 times more confident and focused on the training that they consume. And I'll quickly move on to some of the case study implementations. Like I said, we have implementations across different segments and domains. I'll quickly throw light on some of them. And one important case study is the initial solution which we deployed. This was even during the COVID time when there was there was this ProSec card, PCMS ProSec card from PT Labs, and they were one of the major vendor for Indian Oil Corporation. And this is for a demo of their IoT-based device. This was a compliance device, wherein this device was about 4 to 5 feet in height, and it was pretty bulky. The one which you see on the screen here, this is the actual device, and it actually demonstrated everything in terms of the COVID compliance, like face mask, sanitizer, and it also measures the temperature control and everything. So how exactly do you demonstrate a device like this to your potential clients? And also, how do you give a demo of this, the pretty bulky device? And mind you, this was even done for a smartphone-based VR headset, not even the the latest advanced Oculus or HTC Vive kind of devices. This was done on a low level or a easily accessible smartphone-based VR headset. So it was easy. You had the application on your smartphone, and the device was something that you could carry in your handbag. So you take both of these, and all of these implementing authorities or the implementing organizations were actually large corporate and large industrial enterprises where time was essence, and it was also key to implement these solutions at a faster pace. So this is where we played a key role in terms of developing this entire solution in a smartphone-based VR application. And they saw huge success in terms of the retention and the ability to communicate this as a product training and also as a marketing tool for their potential clients. The next is safety. Safety plays a key role across any industrial or engineering enterprise. And just like how I mentioned about our STEP framework, it plays a key role here in this particular safety aspect. For example, this, the demo that which you are seeing here is of a VR-based safety element, a safety training for how exactly you simulate. These are some high risk and high environment, risk-prone assessment-based modules where which in otherwise is not a easy task where you can easily simulate. So VR plays a key role here in terms of simulating real fire conditions, and that too different scenarios. Let that be if it is a paint shop or a shop floor or different scenarios or different verticals within the larger organization. This lets you simulate fires of different types. For example, you will see a fire of wood, oil-based fire, or if it is a synthetic fire, you would actually have different fire extinguishers for different types of fires. So this will actually let you get trained on these kind of different fire elements, and it would give you an immersive scenario wherein it will give a quick and calm decision-making excitement, and it actually becomes a muscle memory for you to get trained on. And it's a reusable, flexible, and resource-saving training method compared to the physical drills and the safety days and safety weeks that usually happen in a generally happening in the industrial environment. Next is an automotive segment, a case study for the automotive industry, wherein this was a solution that was deployed at SIPCOT. This is deployed in both SIPCOT Chennai and the SIPCOT Hosur facility, a part of the entire, the broader Metaverse Experience Center, wherein we had developed an AR-based, augmented reality-based engine assembly and disassembly training, wherein this gives the users, and this didn't require any kind of costly VR headsets or anything. This was done on the existing tablets and smartphones. And even if you have a good, decent smartphone or tablet, you will be able to try this out yourself. Wherein this was a simulation of a V8 engine, which is one of the most complex. People within the automotive domain will be able to relate to this, wherein one particular engine will have numerous amount of components, and you would be able to simulate these, and it would actually have a complete training that you could do on a tablet, and it minimizes the need for expensive physical engines or physical tools and the broader workshop space that is required. So it saves time on the equipment maintenance, and the users will be able to practice all of these and make mistakes in a risk-free digital environment. So the scope for trial and error increases here, which is in otherwise not possible in a physical environment. So the next is a pharmaceutical deployment, wherein this was for a leading Indian manufacturer, and we have deployed in both VR as well as in AR, wherein this was a VR based. There are these devices like the rapid mixer granulator and dissolution tester. These are the devices that actually transform the powder form, the powder coated, the granules to the powder form, which actually gets to the next stage of the tablet making process. And this goes through the entire safety protocol, the safety procedures, and it guides the trainee through the hazardous operations safely in VR. And healthcare and these pharmaceutical manufacturing domains are some of the key components and key areas which are of highly process oriented, and the accuracy level required was enormous and huge. So that actually plays a key role in terms of how exactly and how relevant these VR and AR solutions are for these kind of scenarios where you need higher level of accuracy in terms of the training and the entire development process. So the nature of the entire AR VR models ensures there is consistent training delivery across all personnel regardless of the location. This facilitates a rapid onboarding, higher accuracy, and it is also easily scalable because all of these devices are all it involves about 35 to 45 different highly complex, high accuracy driven machineries and tools. So this ensures that all of that is in place with these VR and AR based solutions. And moving on, we have solutions deployed at life sciences, and this is a solution that is being deployed at Nepal for a leading Nepal, Kathmandu-based medical college, wherein we had developed an augmented reality and mixed reality-based an interactive 3D complete human skeleton, wherein the medical students would be able to learn the entire bone structure. Access to cadavers are one of the highly complex situation across medical colleges and institutions. This actually eliminates it completely, and it gives you a complete access to the entire bone set, and the users will be able to practice all of the different the bone sets and look at the exact marking data. And this is also highly accurate, and this shows the level of this is actually getting approved by the medical authority. So this shows the level of accuracy to which the way VR and AR and mixed reality based solutions are capable of, leading to higher implementation across even domains like life sciences and medical learning and healthcare, etc. And this would think of it like the Google Meet and Zoom that which we are in, but in a three-dimensional format, and both the students and the teachers will be able to interact real time, just like how they do it in a classroom scenario. And the teachers will be able to annotate, explain where exactly this marking is, take notes, save them, interact real time through voice and chat, and all of those kind of the conventional, interactions that which we have. And on top of that, you have ability to interact and work on 3D models real time and explain it as well. And this is one of our notable implementations in the shipping and logistics space across the VOC Tuticorin port, wherein we had created a digital twin or a digital VR-based 360 video covering the entire, the VOC port, which is about 10 square kilometer, which in other ways, it will take 2 days for you to take a tour of the entire port, but it could be done in just 3 to 4 minutes with our, the VR solution. And even it actually helped them cover some of the key areas which were even inaccessible with the physical format. And this is in a live 360 format, not a 3D replica. So this is even more complex and more realistic, and it connects it to a larger user base as well. Due to the confidentiality factors, we are not able to demonstrate that particular the video showcasing the solution here. But this is a key solution that makes the port accessible to a global audience, including potential investors, new employees, and stakeholders, and people who want to use the ports by all of these large scale companies, etc. And there is one more solution that which we had included at the Radisson Blu hotel chain, and this was a key component that we implemented at Radisson Blu, wherein it tracks the journey of a dish from its origin till the time it comes to your plate. So in the interest of, and this was still in the chat box as well. This is for a real estate architecture and construction space, wherein you would be able to have a virtual tour of the entire villa. Somebody even posted this question in the chat box too. So you will have a high quality 360-degree video as well as a 3D render of the entire virtual tour of a model house or a virtual villa, wherein you could, guests or potential buyers, or even you could have it real time as to how exactly the construction is happening, and also a fully constructed house. Like how you see in the video, you could have a complete virtual tour, and it would be highly realistic compared to the actual uh, residence or the villa plot. This is one more solution for the aviation industry, a complete flight simulation, and the user onboarding journey, from how exactly the entire user onboarding journey will be for the customers, and how the cabin would be like. This would be both as a marketing experience and as a onboarding training for the new joinees. And just like Georgios had demonstrated in this session, this is about a drone operation training. I think in the interest of time, I'll skip the other slides and probably end my session here, and we will be happy to connect further and open to questions. Thank you.
It's time for the Q&A session. So participants can drop your questions here.
Somebody had asked about real estate. I think Rahul Das.
Okay, so
I don't know if I should reply. I think Srini already covered it really well, the real estate. Actually, you sell the house before your house is made. So you have the blueprints and you do not expect it to be finalized in order to see it and buy. You can buy it from the blueprints, but you can see actually how it will look like with solutions like AR and VR. You could have, for example, the blueprints in a paper. You can see that above, how it looks like. You could have your, headset. You can be in your potential house that you'll buy. So that's exactly. And the visual, I think Srini did an amazing work showing how it will look like. Sorry if I stepped in, Srini. You wanted to reply. I think you already covered it really well.
I think you got it perfectly right, and he has also mentioned that he got his answer. Rahul has replied in the chat box. Looks like Nipun has raised. Yeah, Nipun, please go ahead.
Hi, Georgios. My question is mainly,
Hi.
so myself, Nipun, so I work with AR VR from like past 7 to 8 years, and I do gaming for a decade. And my major work I'm currently working is on majorly on synthetic data. So it's been 4 years. I'm working on multiple use cases for synthetic data. My question is mainly related to when you are mentioning about the LiDAR point cloud data simulations. So that is one question is about that. So the first thing is, what kind of ground truths you to plot for LiDAR? So I also work with LiDAR. So my question importantly is like we dump the data of XYZ positions for the LiDAR simulations. Do we also dump the RGB color information or like intensity or something like that? Because real LiDARs dump not just position, it also dumps the material or like maybe classification, whether it's a
the reflection
ground, reflection, strength, intensity. So do we also dump those information or
so
only use position?
Okay, I didn't expand much into technicalities, obviously, in the presentation, but yeah, what we actually did, we had a pre-trained model from Uber. The data set that it used was the Kitty data set. So if you find it online, it's the Kitty data set. It's an open source that actually uses all this information from LiDAR in order to train this model. So what we actually did, we reverse engineer the LiDAR in the virtual world. So we made an urban area where we could have cars, we could have buildings, we could have different kind of elements. And this model from Uber, it was trained to locate cars. It was trained to locate cars. So imagine that you could move around with an Uber. You have the LiDAR above that was, it's turning around in order to emit light Okay, and this actually can identify if there is a car. So what we did inside the game, we have game objects. That's how we call it. The cars from the virtual cars we have in the game, we tag them. We can pre-tag them that this is a car. So when we scan the area with the virtual LiDAR, we had segmented data. Segmented data is do not get all the information. When you have an emission that actually tracks a car, send the XYZ plus the reflection you have. So you have for measurements. That's how we made the reverse engineer. So we imagine that we omit all the noise because in the virtual world, we have the ground truth. So we know exactly where everything is. Okay. So we knew exactly where all the cars were. So after we exported the CSV, we transformed that into a suitable, into a bin file that was that the model actually used. And then what we did, we had this model from the pre-trained model, the pre-trained that used only the real data. It's the kitty data set. So we cross-checked our bin file that we created from the real from our game, and we say, can you identify the cars that are inside in this information? And the model actually it creates the output is a top-down view, and it creates blue boxes with the orientation with a red spot above with the orientation that says here is the car and it's facing this way.
Yeah,
So the output of the model, actually we saw that it felt that there are cars there, but they didn't exist because all this was created in the virtual world. So what we managed to do with that is that the synthetic data can be that good enough in order to be processed as real data. And if they are processed as real data, imagine that you have a scenario, okay, you can move around, you can get, real data sets from, sampling that you do in the streets while you have your self-driving car with the LiDAR. But imagine, can you find that you go around, there is another car, but can you find a flipped car? Or can you find a car that's on fire? You cannot do that, or it's very expensive to find that. But in the virtual world, you can do that. You can flip a car. It's changing the orientation of the car. And you can get another sample with the synthetic data. So imagine that you have all this synthetic information that you have. You have all the information from the real data sets that you have, and you create a more advanced model using all the information. So you could have a lot more advanced AI models using hybrid models that are made both with real data and synthetic data. I hope that I covered your question.
Yeah, I mean, my question was like only that particular. Are you dumping the like reflections or the
X, Y, Z, and the reflection as the data sets we're using, and we actually use one of as a reference the don't remember the exact model, but we got as a reference what the exact model of the LiDAR was. And imagine that what I actually did was I created also a panel that I could change all this information in order to simulate any other LiDAR. So imagine that you could get your data sheet from your model, from your LiDAR model. You can change the preferences that you like in order to address your new LiDAR, virtual LiDAR.
so
X, Y, Z, and reflection. And the reflection is from 0 to 1. 0 is getting nothing, and 1 is the top reflection you get.
So is that material reflection or like what kind of reflection is it? Like what kind of GT it is?
It's the lighting that you have inside with the virtual world. So for example, you could have a direction light that reflects certain amounts of light in the area, or you could have any other. And in fact, I tested that with custom light, and also I created, I even created certain ranges. I read online what are the ranges of the reflections of cars. I think it was 0.6 to 0.5 to 0.7, if I remember well. So I even made a randomized function to get all this information. When you see a car, just put a random number from 0.5 to 0.7. Okay, and even that worked to the model.
Okay, so my next question is like, what do you see the future of synthetic data when I speak about synthetic data? Unity has discontinued its sensor SDK, and also the perception packages are like not getting updated, and like Omniverse is taking over synthetic data more often these days with the USD formats and all. So does like sticking up with Unity as a major platform to generate, simulate digital twin synthetic data, or like is it a good time to like move forward with like Omniverse with its real-time ray tracing and all the ROS communications and all the sense for the majorly for sensor simulations?
I think there is no single answer for that, because you have scientists that are quite trained, for example, in Unity. For example, in my case, I don't expect libraries. I build my own libraries in order to solve problems. So the code, for example, for LiDAR is all, written by me. Also, right now, I have the biggest assistant I can have. I have AI to help me code whatever I like. I know exactly the architecture, and I have AI to help me and speed my process up on what I'd like to create. Obviously, there are great libraries. There are other tools that you may use, as you mentioned, Omniverse, as you mentioned, the ROS library in order to connect even with robotics. This is more for robotics applications. But it all comes back to what developer you are and how experienced you are in certain technologies. You can produce amazing results, using your own tools and stuff. For example, I know how Unreal Engine is, a great engine. They are using C++ or, blueprints, but I stick more to Unity because I have a number of projects. I have so many libraries. I have code that I reuse, and it's a lot easier for me to continue working on that.
Yeah, thanks. I think that's my.
But I think we have one last question from Sajid.
Yeah.
Maybe we'll wrap it up. Yeah.
Can you guys hear me?
Yeah.
Yeah. Hi, Georgios. Great presentation. It was very insightful. And my question is, have you noticed any I'm a digital twin architect, and so I'm interested in building digital twins. Have you noticed with Unity or like Unreal with the amount of data that a scene can hold, getting some type of a bottleneck if you're using those platforms? I've heard that one of the biggest selling points of like OpenUSD and like Omniverse is like it can hold a lot of data to show in your digital twin or interact with. Just curious if you notice as you put more and more data into a scene, do you see any like bottlenecks or performance degradation?
Yeah, it's a very good question. Obviously, the more accurate you are, the more resources you need. The more resources you need, your performance is, not that good, let's say. The thing is that, there are various technologies, as you mentioned. Uh, Also, as I mentioned, I'm more of a Unity developer, but have been working in other technologies too. The thing is that how you approach digital twins and what exactly you'd like to build and what techniques are to get the important information for the digital twin the time you need. For example, I show you the drone project, and after that, I show you the GIS, which is an expansion of this project. So you could have a very large map, a digital twin of the real world, imagine, and you could have a drone flying around the whole Earth. You cannot have the whole Earth in a scene, but you could have a server behind that, and you could have your scene load the specific areas that your drone are. You can have certain drones. You could have, a visible area. Let's say, I don't know, 5 by 5 kilometer. This is a random number for now. But you do not have the whole Earth. And while you approach, you can load another area and unload the previous area. So what actually you do is you get the best of the performance you have, but you load the specific elements you'd like to have for the specific location, for the specific project that you have. Obviously, there are many techniques and some tools are better in some areas. You could have maybe, for example, another tool that is better in terms of processing power and how to handle the different kind of data. But this tool may be not good enough because it does not have other libraries or other material that you need to get. So by using different tools, you win something, you lose something else. But I think you should stick to what you know best, understanding different tools, and actually use techniques to get your performance as best as you can, using performance techniques in order to get the best out of the applications you are building. And also one more thing is that the code you are building, for example, in Unity, you could have, code that runs on CPU and code that runs on GPU. So depending on what you like to build, you should point, for example, you could have shader that's a lot, need more processing power, that you could have that to GPU. So you could have many more elements in order to have the results that you like. So again, depends on the project. It depends on the tool you use. It depends the knowledge you have on the tool, and it depends on the techniques that you use to get the best performance out of each project. Maybe one project is suitable more for one tool and the other for another tool. It's not a solution one size fits all.
Yeah, thanks very much. Yeah, I think you bring up a good point. Like one thing that I've noticed is like, even within Omniverse where they have like the rigid body like dynamics is CPU based, and the actual like, the visualization RTX rendering is GPU. So I guess if we want to improve the performance, we can kind of, change what is used in a scene. That's a good tip. Thank you.
And one more last thing. Omniverse is something that's arising, obviously, but at the same time, what about the Unity community and the Omniverse community? What you have? Who are the supporters of the one? Who are the supporters of the other? Meaning that if you have a question on how to solve something, you go to the Omniverse community and you go to the Unity community. So it's how you back it up. So you have something that you can build upon, and you have something that's more for developer. The game development community is bigger one than Omniverse community, for example. So these are all, some metrics, some ideas that you should also, uh, have in mind when you build something. Because, for example, you can build something from scratch. Use Omniverse or use Unity, but after that, who is gonna use it? And it's the best code ever. So it's you win something, you lose something else, depending on what you like to do.
Yeah, I think just to add to that, I think same thing happened with Godot and Panda 3D, wherein they're like beautiful tools, but we don't have no proper community to support at that end.
Yeah.
Great, thank you.
I mean, that's why we have AI, right?
Yes, sir. Yeah. Thank you. Yeah, over to you, Sheila.
Thank you, everyone. First, I would like to thank Dr. Georgios for taking the time of his busy schedule to be with us and share his insights on cutting edge
I think
XR
it
developments
is
and
a
his
big
future.
applause. Thanks,
Yes.
Georgios, for patiently staying back with
Thank you
us
so
and
much.
answering all the questions. Right? And
Thank you so much for the invitation. It was my pleasure and my honor to be with you.
Thank you very much. We are going to come to you for more. That is what I can tell you.
Yeah.
There are a lot of unsolved problems, and now we know some of these can be tackled by you definitely.
Thank
Very
you so
nice.
much.
Thank you.
Thanks,
Thank you, everyone.
everyone. Have a great rest of your day.
Thank you, everyone. Thank you.
Thank you, everyone.
Yeah.
Thanks.
Bye.